Hello and welcome to New Jersey lesson number 5. This one is on multiple lenses. Because it's on multiple lenses, we're going to need a very long line. So I would pause it and draw a line, maybe a straighter one than I drew, with at least 20 little marks on it, hopefully evenly spaced. They're supposed to represent centimeters. It doesn't have to be exactly a centimeter between each one. I just drew it, tried to do my best. You can see it's a little wobbly, with a line in the front for my object. When you have more than one lens, you do each lens one at a time. So we're going to put a lens, and we're going to put a lens on 3 centimeters from the front. So 1, 2, 3, and we're going to put a convex lens with a focal point of 2. So we're going to write lens number 1. Oh, and by the way, make sure you have a little bit of room on top, or you make a small arrow, because the final result is going to be taller than the original. Okay, lens number 1. The original distance is 3 centimeters, or 3 millimeters, or whatever you want to do. 3 marks. And the focal point is 2 centimeters. So let's start with drawing the thing. We're going to start with green, because why not? So it starts at the top of my object, it goes horizontal, and then it goes through the focal point. The second one starts at the top, goes through the center, and these two happen to meet. And they happen to meet right at about, well, they were supposed to meet, I'm going to fake it so it meets exactly at 9. Did it meet exactly at 9? Nah, I'm kind of faking it. Why didn't it meet exactly at 9? Because, the lines are a little wobbly. That's why it didn't work perfectly. So for lens number 1, we're going to use the equation to find out where it is. 1 over di equals 1 over the focal point, 2, minus 1 over do, which is 3. This is 1/2 is the same as 3/6 minus 2/6, which is 1/6. Di is 6 centimeters. Now wait a minute, I said 9, not 6. But it's 6 centimeters from this lens. Just like this is 3 centimeters behind the lens, this is 6 centimeters in front of the lens. If this is our 0, then 3 plus 6 is 9. Okay, let's also do the magnification. The magnification is going to be the distance we started, the distance we ended, divided by the distance we started. It's going to be 2 times bigger. So this one is about twice as big as what we started with. It will also be negative because it's upside down. So this is going to be negative 2. It's 2 times as big and it's upside down. But this is only one lens. What if we add another lens? Let's add another lens, and we're going to make it easy. We're going to add another lens at position 12. Lens number 2 is going to be at position 12. Why did I pick position 12? Because it's 3 centimeters in front of this image. And we're also going to make it have a focal length of 2. So lens number 2. The focal length is 2 centimeters. What is the distance? Well, we're not going to do the original object. What we're going to do is say the image from the first lens is our object for the second lens. Let me say that one more time. The first lens makes an image. We're going to use that as our object for the second lens. So in order to find the first distance, the distance of our object, we want to know the distance between here and here. The distance between our new arrow and our lens. And that distance happens to be also 3 centimeters. Why did I make it that way? Because I'm lazy and wanted to make the math simple. So I'm going to draw it with a different color. Let's make it with red. This is our new object. So we're going to start with our new object, go horizontal, and then through the focal length. Oops, I hope I have enough room. And then the second one is going to go from the top of our object, through the middle. And these two meet at about here. So this is our final image. I'm sorry, how much time? I have 5 minutes. Thank you. Sorry, I can only do 10-minute things. That means 5 minutes. We probably should have figured that out before we started recording. Okay, so, sorry. This one makes an image that's twice as big and upside down. This one makes an image that's also twice as big and upside down. So this one makes an image that is, we can do the same equation. We get DI equals 6 centimeters. Not at 6 centimeters, but 6 centimeters in front of the second lens. And we also get the magnification is -2, which means it's 2 times bigger than the green one and flipped. So once we have 2 lenses, we get twice as big and flipped, and then twice as big and flipped. So the total is -2 times -2. The total is 4 times as big and not inverted. This is what you would use for magnifying, for a microscope, sorry. If you wanted an image that's 4 times as big, you have 2 lenses and you put them a distance apart where you get a real image 4 times as big. And how did I get 4? -2 times -2. You can also see that it's bigger and much bigger. Okay, the next question is, how do you deal with cases where the image from the first lens is behind the second lens? And we're going to do that in our next lesson, lesson number 6, because otherwise it takes too long to put on YouTube. See you in a bit.